Now that we've finished looking at the three types of experiments we'll use in this class, the basic randomized comparative experiment, the randomized block design, and matched pairs, let's take a look at what you do once your experiment is finished and you have these results. So if the differences among the treatment groups are big enough, we'll attribute the differences to the treatments. So in other words, if we've randomly assigned our participants to treatment groups and our results are really different, then we're going to say that the treatment caused that difference in the response variable. So a natural question here is, how do we decide whether the differences are big enough? I mean, we definitely don't expect that those groups are going to be identical, but at what point do we say, yeah, it's close enough versus, wow, that's really a big difference? So are the differences, the results we observed, what we might expect from random variation alone, so just kind of close, but not identical, or are they a lot bigger than that? If we decide that they're bigger than random variation alone, we're going to conclude those treatments cause the bigger differences. And in statistics, what we say is this means that the differences or the results are statistically significant. So you've probably heard that phrase before, and that's what it means. It means the results of your experiment were pretty different in a way that you were amazed or surprised. So you concluded that that treatment is what caused that difference. So a set of observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. That's a little bit of a mouthful, and as we move through the last 2 units in this class, we'll actually be able to calculate those probabilities and take a lot better look at that. But for right now, we're going to kind of go with just our impression of, wow, that's a really big difference that I wouldn't have expected, or it's probably close enough. So, for example, if I flip a fair penny 100 times, I would expect to get roughly 50 heads. If I got 94 heads out of 100, I would say that there is something wrong with this coin, and those differences or that result is statistically significant. So another example, suppose that in a poll of 1,000 randomly selected people, 51% support the president. A week later, in another poll with a different random sample of 1,000 people, only 49% support the president. Should we conclude that the opinions of all Americans have changed significantly during that 1 week between the polls? I would say no. 49 to 51, there's some error in these polls. And so I would say that's definitely within the error range. So this is not a statistically significant difference. However, what if the poll results had fallen from 70% support 1 week to 30% the next week? Then we would say, yeah, that's statistically significant. Like, what happened to create that large of a change?